Hi friends, we studied that a complex network can be simplified and analyzed using KVL and KCL methods. An improved version of KVL and KCL methods are mesh analysis and nodal or node analysis. Although we are using KVL and KCL in mesh analysis and nodal analysis, we can reduce the number of calculations compared to KVL and KCL. In this class, we will study about mesh analysis. For mesh analysis, the given network must be planar. What is a planar network? Planar network. See, in this network, the branch R4 is crossing the branch containing R3. So, this cannot be said as a planar network. A planar network is that which can be drawn on a paper without any crossing over like this. The same figure can be drawn without this crossing if it is drawn like this. See here, now we have brought this R4 in this way without crossing any other branches. See this case. In this network, the branch containing the voltage source is crossing the branch containing R2. This one cannot be drawn in any other way so that it is not crossing any other branches. Even if we are drawing in this way to here, it will cross here. If we are drawing in this way, it will cross here. So, in this network, the branch containing this voltage source cannot be drawn without any crossover. So, this is a non-planar network. Now, we will study the steps for mesh analysis. First, make sure that the given network is planar. For example, see this network. See here, no crossover is there. So, this network is a planar network. Then, identify the meshes in that network and mark it as 1, 2, 3. Here, only 2 meshes are there. We will mark it as 1 and then 2. Then draw the mesh current in each mesh as I1, I2, etc. either in clockwise or anti-clockwise. We will follow clockwise. I1 is for mesh 1, I2 is for mesh 2. Then mark the direction of current flow in each element and mark with the plus and minus sign. That is while entering positive and while leaving negative. See in V1, mesh current is flowing from minus to plus, that is rise in voltage, so it is positive. While in mesh 2, I2 is flowing from positive to negative or fall in potential, that is negative. Then we will mark the direction of current flow in these resistances. See, while this mesh is considering, we have to write the direction of current as per this mesh. I1 is entering here, that is plus, while it is leaving from here, that is minus. For R2, in this mesh, I1 is entering here and leaving here. So, this is minus. As far as I2 is concerned, in this mesh, I2 is entering R3 here. So, it is plus, leaving here. So, this is minus. For R2, I2 is entering here. So, this is plus, leaving point is here. So, this is minus. See, for R1, only I1 current is there. So, voltage drop is minus I1 R1. Similarly for R3, here only I2 is coming, so voltage drop will be plus to minus, that is minus I2 R3. See the case of R2. Here both I1 and I2 are coming. Then there arises a confusion which is to be written first. That is, while considering this mesh, it must be written as voltage drop is minus R2. Minus is because it is from positive to negative into the mesh which we are considering must be written first minus I2, the other mesh. While writing the voltage drop for R2 in this mesh, see the current is flowing from positive to negative, so minus R2 into current, difference in current, as both are in opposite direction. Here in this mesh, as it is mesh 2, I2 must be given preference minus I1. So here the voltage drop will be minus I1 R1. Here the voltage drop is minus I2 R3. Next step is we have to write the mesh equations for each meshes applying KVL, that is Kirchhoff's voltage law. For mesh 1, see here minus 2 plus, that is rise in potential. So plus V1, here plus to minus, that is voltage drop, current into resistance, minus I1 into R1. See here, two currents are there. I1 is in this direction, clockwise direction, while I2 is in the opposite direction. So now we are considering mesh 1. So here I1 is flowing from positive to negative, minus R2 into, while we are in mesh 1, I1 must be written first, minus I2, which is in the opposite direction. So the algebraic sum of all is equal to 0. Expanding, V1 minus I1 R1 minus I1 R2 plus I2 R2 is equal to 0. See, I1 is here and here. So minus I1 into R1 plus R2 plus I2 R2 is equal to minus V1. When we are bringing this V1 to right hand side, changing the sign, I1 into R1 plus R2 minus I2 into R2 is equal to V1, which is equation 1. Similarly for mesh 2, in V2 current I2 is flowing from positive to negative, that is fall in potential, minus V2, then R3 plus to minus, that is voltage drop, minus I2 into R3. Then here voltage drop in R2 is, the current I2 is flowing from positive to negative. When we are considering this loop, we have to consider I2. So I2 is flowing from positive to negative for R2, and then it is minus R2 into, as we are in mesh 2, I2 must be given preference, I2 minus I1 is equal to 0. Expanding, minus V2 minus I2 R3 minus I2 R2 plus I1 R2 is equal to 0. Taking V2 to right hand side and writing I1 R2, here I2 is in these two. So minus I2 into R3 plus R2 is equal to V2 when bringing V2 to right hand side. This is equation 2. Solving equations 1 and 2, we will be getting values of I1 and I2, and we can find the voltage drops using I1 and I2. In this example, we are asked to find the mesh currents I1, I2 and I3 in the circuit shown in figure using mesh analysis. First of all, we have to make sure that the given network is planar. Here no crossings are there, so this is a planar network. So we can apply mesh analysis. Now we will mark the three meshes. This is mesh 1, mesh 2 and this is mesh 3. Then we will draw the mesh currents. Here it is I1, I2, I3. When I1 is concerned, we will mark the polarities of the resistances, that is entering point plus, leaving minus. For 20 ohm resistance in this mesh, here it is entering and here it is leaving. In this voltage, it is from minus to plus, that is rise in voltage. For this resistance, current is entering here, so we have to mark it as positive. Here it is negative, where it is leaving. For this resistance, inside this mesh, I2 is entering at this point, so it is plus, and leaving at this point, so it is minus. As far as I3 is concerned, for 10 ohm resistance, it is entering here, so it is plus, leaving from here, so it is minus. For this 10 ohm resistance, when I3 is concerned, here it is entering and leaving from here. For this 20 ohm resistance, I2 is entering here plus, leaving from here, it is minus. Now we will write the mesh equations for the three meshes using Kirchhoff's voltage law. For mesh 1, for this 10 volt, it is fall in potential, so that is minus 10. For this resistance 10 ohm, positive to negative, so voltage drop is there, 10 into I1 minus 10 I1. For 20 ohm resistance, when I1 is concerned, it is going from positive to negative, so drop is there, minus 20. As we are in mesh 1, we have to write the mesh current I1 first, minus I2, which is in the opposite direction. This is equal to 0. For mesh 2, here we are going from minus to plus, so plus 40, rise in potential. Then here positive to negative, so voltage drop in 20 ohms is 20 into mesh current I2. So as it is voltage drop positive to negative, minus 20 I2. Here also rise in potential, minus to plus, plus 10. Here in this loop, as I2 is flowing from plus to minus, voltage drop is minus 10 into, as we are in mesh 2, I2 must be written first, minus I3 which is going in the opposite direction. Next comes I2 through 20 ohms, it is flowing from positive to negative, so minus 20, we are in mesh 2, I2 is to be written first, minus I1 which is in the opposite direction. So the algebraic sum is equal to 0. For mesh 3, here I3 is flowing from positive to negative, so voltage drop in 10 ohm is minus 10 into I3, plus here it is rise in voltage, so plus 50, then in this resistance, as I3 is flowing from positive to negative, voltage drop is there, minus 10 into, as we are in mesh 3, minus 10 into I3 minus I2 which is in opposite direction, then this voltage is from plus to minus which is drop in voltage, so minus 10 is equal to 0. This is equation 1, this is equation 2 and this is equation 3. Now we will take equations one by one, expand and simplify. Equation 1 can be written as, while expanding, minus 10 I1 minus 20 I1 plus 20 I2 is equal to 0. Transferring this minus 10 to the other side, this will become minus 10 I1 minus 20 I1 plus 20 I2 is equal to 10. Here this minus 10 I1 and minus 20 I1 can be added and written as minus 30 I1 plus 20 I2 is equal to 10. Dividing the equation by 10, it becomes minus 3 I1 plus 2 I2 is equal to 1. Let this is equation 4. Now we will expand and simplify equation 2 of mesh 2. That is, equation 2 becomes, in equation 2 we can add this 40 and 10, that is 50, and we can bring it to the other side. Expanding it, minus 20 I2 minus 10 I2 plus 10 I3 minus 20 I2 plus 20 I1 is equal to plus 40 and plus 10 added together plus 50, while bringing here it becomes minus 50. Rewriting, here this 20 I1, then minus 20 I2 minus 10 I2 and minus 20 I2 is there. It becomes 20 plus 10 plus 20 minus 50 I2 plus this 10 I3 is equal to minus 50. Dividing by 10, this becomes 2 I1 minus 5 I2 plus I3 is equal to minus 5. Let it be equation 5. Now our third equation becomes, while simplifying, minus 10 I3, then plus 50 minus 10, that is plus 40, minus 10 I3 plus 10 I2 is equal to 0. We can move this 40 to right hand side, so it becomes this 10 I2, then minus 10 I3 and minus 10 I3. It becomes minus 20 I3 is equal to, while we are moving plus 40 to the other side, it becomes minus 40. Dividing by 10, the equation becomes I2 minus 2 I3 is equal to minus 4. Let this is equation number. Simplifying equations 4, 5 and 6, we will get I1 is equal to 1 ampere, I2 is equal to 2 ampere and I3 is equal to 3 ampere. In this example, we are asked to find the current in each branch of the circuit using mesh analysis. We know that this is a planar network, so we can apply mesh analysis. Here first we will mark the meshes. Let this is mesh number 1, this is mesh number 2 and this is mesh number 3. Then we have to draw the mesh currents in each mesh. Let I1 is the mesh current in mesh 1, I2 the mesh current in mesh 2 and I3 the mesh current in the third mesh. Next we have to mark the direction of current flow in each element. See, in this resistance current is flowing in this way, so it is entering here, so we have to mark it as plus, and leaving point as minus. In this resistance it is entering here plus, here it is minus. In 30 ohm resistance entering here is plus and leaving point it is minus. In this mesh in R2 it is entering it in this point, so here we have to mark plus and here it is minus. In this resistance here it is entering plus and leaving point is minus. Then while current is coming here, here is rise in potential. After this the 60 ohms resistance is coming, where at the entering point it is plus and at the leaving point it is minus. The third mesh in this 40 ohm resistance, at the entering point it is plus and the leaving point it is minus, and this 10 ohm resistance here it is plus and at the leaving point it is minus. Then here is rise in potential. In this battery also there is rise in potential minus to plus. Then in 50 ohms in this mesh I3 is entering here and leaving here in the 50 ohm resistance. Now we have to write the mesh equations for each mesh applying KVL. For mesh 1, see here it is entering here and leaving here. So voltage drop in 20 ohm resistance is I1 into 20, that is 20 I1. As it is plus to minus, we will give minus 20 I1. Then in 40 ohm resistance it is entering here and leaving here, plus to minus, so it also is minus 40 into, here two currents are flowing, I1 in this direction and I3 in this direction. So the current flowing will be the difference between I1 and I3. As we are in mesh 1, we have to write I1 first, then I3. Then in 30 ohm resistance, I1 is entering here, the plus point, and leaving minus point. So minus 30 into current is the difference between I1 and I2. But as we are in mesh 1, I1 is to be written first, minus I2 is equal to 0. Let this is equation 1. Then for mesh 2, in the 30 ohm resistance, current I2 is in this direction and I1 is in the opposite direction. So here current is entering at this terminal which is positive, then leaving here it is minus 30 into difference of currents between I1 and I2. As we are in mesh 2, we have to write I2 first, then I1 which is in the opposite direction, so minus I1. Then the next voltage drop is in 50 ohms, so as it is from plus to minus, minus 50 into difference in current is I2 minus I3. As we are in mesh 2, we have to write I2 first, minus I3. Then comes this 20 volt source, where it is flowing from positive to negative terminal, that is drop minus 20. Then here 100 volt is coming, which is from negative to positive, rise in potential, so plus 100. Here it is positive to negative, drop in potential, minus 60 I2. So the algebraic sum is equal to 0. Let this is equation 2. Then writing equation for mesh 3, see I3 current is flowing in clockwise direction. In 20 volt it is going from negative to positive, that is rise in potential, so it is plus 20. Then this resistance is coming where the I3 is flowing from plus to minus, that is drop in resistance, so minus 50, difference between I3 and I2 which are in opposite directions. So as we are in mesh 3, we have to write I3 first, minus I2. Next comes this 40 ohm resistance. Here also current is flowing from plus to minus, so voltage drop is there, 40 into I3. As it is from plus to minus, minus 40 into difference of current in mesh 3 and mesh 1, that is I3 minus I1. Then here also positive to negative in 10 ohm resistance. Here voltage drop is there, minus 10 I3. Then this 50 volt is coming, where it is minus to plus, which is rise in potential, which is plus 50, where the loop is completing, and this is equal to 0. Let this is equation 3. Expanding and simplifying these equations, equation 1 becomes minus 20 I1 minus 40 I1 plus 40 I3 minus 30 I1 plus 30 I2 is equal to 0. This minus 20 I1 minus 40 I1 and minus 30 I1 can be added and written as minus 90 I1. Then this plus 30 I2 plus 40 I3 is equal to 0. Let this is equation number 4. Then expanding and simplifying this equation, second equation, it becomes minus 30 I2 plus 30 I1 minus 50 I2 plus 50 I3 minus 20 plus 100 minus 60 I2 is equal to 0. Rewriting, 30 I1 comes here, then this minus 30 I2 minus 50 I2 and minus 60 I2 can be added and written as minus 140 I2. Then we will write plus 50 I3 is equal to minus 20 plus 100. This is 80. 80 we will transfer to the other side. So it becomes minus 80. Let this is equation 5. Now expanding and simplifying this equation 3. The 3 becomes plus 20 minus 50 I3 plus 50 I2 minus 40 I3 plus 40 I1 minus 10 I3 plus 50 is equal to 0. Simplifying, 40 I1 then plus 50 I2, and here minus 50 I3, here it is minus 40 I3 and here it is minus 10 I3. Adding these three, minus 100 I3 is equal to minus 70. Let this is equation 6. Solving equations 4, 5 and 6, we will get I1 is equal to 1.49 ampere, I2 is equal to 1.65 ampere and I3 is equal to 2.12 ampere. Therefore, branch currents are, see here mesh current is I1 which is flowing through this 20 ohm resistance, and branch current in CD is equal to this I1 which is, we got it as 1.49 ampere. Branch current in BH is difference between mesh current I1 and I2, that is equal to I2 minus I1 which is 0.16 ampere. Then branch current HE is difference between mesh current I1 and mesh current I3, that is I3 minus I1 which is equal to 0.63 ampere, and branch current in HG is difference of current I2 and I3, that is branch current in HG is equal to I3 minus I2 which is equal to 0.47 ampere. Branch current in AG is also flowing in the branch AB as both are belonging to mesh 2. So branch current AG is equal to branch current AB is equal to I2, that is 1.65 ampere. Then this branch current GF and EF are same, that is I3. So branch current in GF which is the same as branch current in EF which is equal to I3, that is 2.12 ampere. I think this class also might have been useful to you. If you found any difficulty in understanding any portions of this class, please refer to my previous classes, the links of which are given below. Thanks for watching my video. Please like it, share it and subscribe it by pressing that bell button. See you next time. Bye.